Students, today we will solve some numerical problems based on Millikan's oil drop experiment. At first, let us review the formulas. As you know, in Millikan's oil drop experiment, the oil drop is sprayed with the oil spray through the narrow hole in the upper parallel metal plate, falls with terminal velocity in air, and in absence of electric field, if V1 is the terminal velocity of oil drop, charged oil drop, then the radius of drop is given by the relation R is equal to 9 eta V1 upon 2G rho minus sigma, where eta is the viscosity of air, rho is density of oil, and sigma is density of air. Now if we switch on the electric field, means if we apply electric field E of value V by D, where V is the potential difference between two plates and D is the separation between two plates, then the drop falls with terminal velocity V2 downwards. Then we get the charge on the drop, which is equal to N into E, is equal to 6 pi R eta V1 minus V2 upon E. Here V2 is the terminal velocity of drop, charge drop, with electric field switched on. Now here we have to take minus sign if the drop is coming downwards, and we will have to take positive charge, positive symbol sign when the drop moves upward. Now first question is, in Millikan's oil drop experiment, a charged oil drop falls with terminal velocity 1.4 millimeter per second in absence of electric field. When a vertical electric field of 4.9 into 10 to the power 5 volt per meter is applied, then the drop falls with terminal velocity 1.21 millimeter per second. Calculate the charge on the drop. Density of oil, density of air, and viscosity of air are given. Now solution. Because the drop is falling downwards on the application of electric field, therefore charge on drop will be Q is equal to 6 pi R eta B1 minus B2 upon E. Here E is given to be 4.9 into 10 to the power 5 volt per meter. B1 is terminal velocity in absence of electric field, 1.4 into 10 to minus 3 meter per second. Similarly, terminal velocity in presence of electric field is 1.21 into 10 to minus 3 meter per second. Viscosity of air is 1.81 into 10 to minus 5 kg per meter per second. Density of oil is 750 kg per meter cube, and density of air is 1.29 10 to power 1.29 kg per meter cube. Suppose this is equation 1. Now radius of drop R is equal to 2 9 eta B1 upon 2g rho minus sigma square root. So by putting the values we get 9 eta means 1.81 10 to minus 10 to power minus 5 b1 1.4 into 10 to minus 3 upon 2g means 9.1 9.8 rho minus sigma 750 minus 1.29. On simplification we get R is equal to 3.94 into 10 to minus 6 meter. Therefore equation 1 gives Q is equal to 6 by R is this much 3.94 into 10 to minus 6 eta 1.81 10 to minus 5 b1 minus b2 b1 is 1.4 minus b2 is 1.21 both are in millimeter, therefore 10 to minus 3 may be taken common upon E. E is given to be 4.9 into 10 to power 5. On simplification we get charge as 5.21 into 10 to minus 19 coulomb. Next question is, in Millikan's oil drop experiment, the horizontal plates are 1.5 cm apart with upper plate at plus 1500 volts. With the electric field switched off, a charged oil drop falls with terminal velocity 2.5 into 10 to minus 2 cm per second. When the electric field is switched on, the drop remains stationary between two plates. Find the radius of drop, number of electrons on the drop. Find terminal velocity of the drop when it gains 2 more electrons. Density of air is negligible and density of oil and viscosity of air are given. So in first part, radius of drop is given as R is equal to 9 eta V1 upon 2g rho minus sigma power half. Here V1 is terminal velocity in absence of electric field means 2.5 into 10 to minus 2 cm per second and divided by 100 it gives 2.4 into 10 to minus 4 meter per second. Density of oil is 900 kg per meter cube and density of air is negligible. G is 9.8, therefore R will be equal to under root 9 into eta is 1.8 into 10 to minus 5 Newton second per meter square SI unit it is in. So it is 9 into 1.8 into 10 to minus 5 into B1 2.5 into 10 to minus 4 whole divided by 2 into 9.8 into 900 minus 0 whole power 1 by 2 and on simplification we get the radius of drop as 1.5 into 10 to minus 6 meter. Now in second part, charge Q will be equal to 6 pi r eta B1 minus B2 upon E. Here E is V by D, B is 1500 volt and D is 1.5 cm means 10 to minus 2 meter, and this gives 10 to power 5 volt per meter electric field intensity. B2 is 0, stationary. We have calculated R, therefore Q will be equal to 6 pi, R is calculated here 1.5 into 10 to minus 6, eta 1.8 into 10 to minus 5, B1 is 2.5 into 10 to minus 4 and B2 is 0 upon E, which is 10 to power 5. On simplification we get the charge on the drop as 12.7 into 10 to minus 19 into 10 to minus 19 coulomb. But Q is equal to N into E, therefore N will be equal to Q divided by electronic charge E. Here Q is 12.7 into 10 to minus 19 and E is 1.6 into 10 to minus 19. On simplification we get 7.9, which is close to integer 8, and therefore N will be 8 electrons. In third part, if the charge gains 2 more electrons, then the will, if the drop gains 2 more electrons, then total charge on the drop becomes Q dash is equal to 8E plus 2E means 10E, that is 10 into 1.6 into 10 to minus 19 coulomb, or to 16 into 10 to power minus 19 coulomb. Because the charge is increased, therefore and it will move upwards because of the increase of upward electric force. So in this case we will have to use Q dash is equal to 6 pi r eta B1 plus B2 dash, new velocity, terminal velocity B2 dash upon E. Here positive sign is used due to upward motion of electron. Therefore E Q dash will be equal to 6 pi r eta B1 plus B2 dash, or B1 plus B2 dash will be equal to EQ dash divided by 6 pi R eta, and therefore B2 dash will be equal to EQ dash upon 6 pi R eta minus B1. Now putting the values, we get B2 dash as B2 dash E is 10 to power 5, Q dash is 16 into 10 to minus 19 upon 6 pi R is 1.5 into 10 to minus 6, 10 to minus 6 into eta 1.8 into 10 to minus 5 whole divided by, whole minus B1. B1 was 2.5 into 10 to minus 4. On simplification, we get new terminal velocity as 6.4 into 10 to minus 5 meter per second. With this terminal velocity, the drop will be moving upwards in this case. Next question is, an oil drop of mass 3.25 into 10 to minus 15 kg falls vertically between two parallel metal plates in air which are 2 cm apart. When a potential difference of 1000 volt is applied between two plates, the drop moves towards the positive plate at an angle 45 degree with vertical. Find the charge on the drop. Now solution. According to question, suppose these are two parallel metal plates. Distance between two plates is 2 cm, means 0.02 meter, and potential difference is 1000 volt. V is equal to 1000 volt. In the electric field, the drop moves towards the positive plate. So suppose V is the velocity of oil drop, which makes angle 45 degree with the vertical, so 45 degree with the horizontal. Now its component along horizontal is suppose V1 and along vertical is V2. So the viscous force along horizontal will be equal to 6 pi r eta V1, and along vertical it will be 6 pi r eta V2. This will balance, or this will be equal to the electric force, and this will be equal to the magnetic force. Therefore, if B1 and B2 be the horizontal and vertical components, of terminal velocity V, B of drop, then we must have 6 pi r eta b1, this is horizontal component, will be equal to electric force, equation 1, and 6 pi r eta b2 will be equal to mg, will be equal to weight. Therefore, equation 1/2 gives EQ upon mg will be equal to B1 upon B2, and B1 upon B2 will be this is B1 upon B2 will be equal to tan 45 is equal to 1. This means that EQ will be equal to mg, which gives Q as mg upon E. M is 3.25 into 10 to minus 15, G is 9.8, and E is 1000 upon 0.02, means V by D. So, on simplification we get, therefore, we get charge on the drop as 6.37 into 10 to minus 19 coulomb. Next question number 4 is, in Thomson's experiment, the potential difference between plates is 50 volts and their separation is 3 centimeter. The magnetic field applied to make the electron beam undeflected is 10 to minus 4 Tesla. What is the velocity of the electrons passing through the plates? Solution: as the electron beam is undeflected under the presence of electric and magnetic fields, therefore the two fields must be crossed fields, as the electron beam is undeflected, therefore electric and magnetic fields are crossed fields. Therefore, electric force on electron will be equal to magnetic force on electron. This gives velocity V as E cancels out. V is equal to E upon B, because E is equal to V by D. Therefore, V will be equal to velocity V will be equal to V by D upon B. Now putting the values, V is 50 volt, D is 3 centimeter means 0.03 meter, and B is 10 to minus 4 Tesla, because D is 3 cm, which is 0.03 meter, B is 50 volt, and B is 10 to minus 4 Tesla. So on simplification we get velocity as 16.67 10 to power 6 meter per second.